Hi, my name is Dan Chitwood, and I'm an assistant professor at Michigan State University in the Department of Horticulture and Computational Mathematics, Science, and Engineering. Welcome to the third video tutorial of Plants and Python. In this video, we'll be learning to visualize data using matplotlib. The Python learning objectives for this video are that lists can store numerical data and that it can be plotted. We'll learn how to load in modules, sets of functionalities that allow us to do tasks in Python, how to create plots, scatter plots, and filled polygons, how to manipulate the shape, size, and color of elements in plots, how to plot data on top of each other and to use a legend, and how to create subplots, or different figure panels within one plot. The plant learning objectives are that phenotype is what a plant is, and that phenotype is something that can be measured. Genetic differences between closely related species result in variation, and as an example today, we'll be measuring morphology. It's one aspect that we can measure using geometry. So let's get started. As you learned in the previous lessons, lists are things that can store data, including numerical data. But we can use lists and the data within them to plot the data. So in this cell is the data that we'll be looking at today. These are lists that contain X and Y values for the average leaf outlines, the average shapes of 15 grapevine species. These species are from the genus Vitis, which is where wine and table grapes come from, and also a related genus of species called Ampelopsis. Each of these lists correspond to a species, like this one here is Ampelopsis acutifolia, and the first capital letter of the list is the genus name. The next three letters are the letters of the species epithet, and these lists are the X values or the Y values for each of these species. So these lists are somewhat long. You can see that they're filled with numbers, and they are for 15 grapevine species. And at the end of this cell, we have the overall average shape of the grape leaf. So to create these lists, as you know, all we have to do is press Shift-Enter to execute the cell. And now we have all these lists with these numbers, which we can look at through plotting. So next, before we plot anything, we have to learn how to load in modules. Modules are sets of functionalities that allow us to do common tasks in Python. The module that most people use to plot is matplotlib, and it's used quite often. The way we load in matplotlib is that we use import. So we type out import, and then we type matplotlib. We also type .pyplot because this is a submodule that we'll be using for plotting. When you use the functions in a module, you have to refer to them by name. So you'll say something module.function. It would be a lot to write matplotlib or pyplot every single time you use a function. So we import matplotlib as plt, because as you'll see, all we have to do is write plt.function, which makes things very simple. For matplotlib specifically, there's a second line of code. This is %matplotlib space inline. And this is a special line of code that allows us to display plots inline. Matplotlib is so commonly used that a lot of people just, every single time they use Python or a Jupyter Notebook, they will just execute these two lines of code to import matplotlib because it is used that often. So you can just copy and paste this every time you use a Jupyter Notebook, and matplotlib will be there for you to use. Okay, so we have loaded in data. These are lists of X and Y values. We have imported matplotlib so that we have the functions to create plots. So let's actually create some plots now. So if you remember, we have these lists for each species. This one in this example is Ampelopsis acutifolia. These lists were for the X values and the Y values. So remember that when we use a function in matplotlib, one of these functions is plot, because as you'll see, it creates a plot. We have to refer to the module. And we imported it as plt. So we write plt dot, and then we write the function. And then we place as an argument in this function a list of values. And so these are the X values for Ampelopsis acutifolia for its leaf, and let's see what happens when we press Shift Enter. So you can see that we get a plot. It should be displaying within your Jupyter notebook. The y-axis is actually the x values. So this line, these are the x values along the y-axis. And the x-axis here is the order of those values. The reason it looks like this is because we only have x values, so it just plots values along the y-axis and their order, just as it finds them in the list. We could do this for the y values, though. So you can say plt.plot and put in a list of y values, and now you get the same thing. It's just y values in the order that matplotlib finds them. The whole point here, though, is that we're trying to visualize leaves, and so we have a list of x and y values. We need to put them together to have actual coordinates, and this is very simple. You have your plot function again, and you just do a list of x values, and you put in a list of y values. And now, when you create the plot, you can see that matplotlib puts the x and y values together, and it creates a line in the order that it finds these coordinates. And here we get something that looks like a leaf. So this is the tip of the leaf, this is the base of the leaf, and you can see this is a very deeply lobed leaf that looks like a star. So this is the plot function. It creates a line connecting the points, but there's other functions. So maybe you've heard of something called a scatter plot. A scatter plot, if you have point data like we have here, it'll just create points. So if we say plt.scatter, but put the same x and y values in, instead what we get is those points, not the line. Another function is fill. So if we say plt.fill, we won't get a line points back. Instead, we get a filled polygon. You can actually just keep on adding these functions on top of each other, and you'll see that this is one of the most powerful ways to create complex visualizations. You can use the plot function, the scatter function, and the fill function all together, and you can see what you get is you get a line, an outline of the leaf connecting the points, you get the points, and you also get a filled polygon. So you can just keep on adding different functions in matplotlib, executing them one after the other, and it's just like pasting over on top of what you have already plotted. There's numerous other functions that you can use. For example, you can use plt.xlim and ylim to modify your plot. So let's say we wanted to limit the x and y values to just between negative and positive 100. And you can see now, for example, that this cuts off our leaf. So you've seen the very basic functions of plot, scatter, and fill, but you can do a lot more than that. So let's see how we can manipulate the shape, size, and color of elements in these plots. So remember hashtags, as you've been seeing throughout these notebooks, that this is a way for Python to ignore any code or text that you put after a hashtag. Here I've hashed out everything except the very basic plot that you just saw in the previous cell. So this is where we ended before. And here in these hashes, I'm showing you all these different arguments you can use. Things like color, line style, line widths, size, alpha, which is how transparent something is, aspect ratios, titles, x-axis labels, and even turning the axis labels on and off. So this is the main point of this video tutorial and the activity associated with this lesson, which is to explore all of these parameters and all the choices you have so that you have the power to create the graphs and visualizations that you want. So one by one, I'm going to take these and we'll kind of explore all the different ways you can manipulate these graphs. So for example, the plot function, we can change the color. There's a shorthand in Python for the colors. You can just use letters sometimes to denote a color. So for example, K refers to just black. So we can put color K. Notice that the lines are blue right now, but if we say K for black, now they are black. It's just a simple line at this moment, but we could say line style equals colon. And instead of a straight line, now we could get a different style. For example, a dotted line. And we can say also, let's say we want a wider line. We could say line width equals 3, something more than 1, which it is right now. And you can see we get a much thicker line. So that's for the line, the plot part. What about the scatter? So let's say we want color to be dark orange. I'm going to show you a link after this where you can look up all these colors and how to refer to them. So if we say color dark orange, you can see that the points become dark orange. And then S refers to size. So let's make these points really big. So let's say size equals 80. And now you could see these points are really big. We could, let's see if we go to 800, what it would look like. Really big. Let's say something more like 200. So we have some big points now. For the fill of the polygon, another color scheme we can use is something called hex codes. So if you'll notice, this is a series of 6 characters, and they have a hashtag before them, and they have quotations because they're a string. And this is a specific color. It's a green color in this case. This is a way to encode all the colors. And again, I'll show you a link where you can find your own hex codes. And it gives you a lot of power in selecting the exact color that you want. Next, we have something called alpha. And alpha is a transparency. So when alpha is set to 1, which is default, the object is not transparent. But if we set it to 0.5, then it's halfway transparent. And if you notice now, because this is the fill of the polygon, that now you can see, because we made the polygon half transparent, you can see, for example, that the points are showing through partly. If you noticed, the scale of these axes is not consistent. It creates kind of a warped leaf. So there's a way to set aspect ratio for these axes, set aspect. We want them to be equal. So if we execute this, now you can see that we have a box, and that the spacing between the axes is proportional. There's 2 different options you have, box or data lim. Box forces the plot to be a box, but data lim will create equal axes, but it will allow the axes to go as long as they need to have all the data within the plot. So it's not forcing it to be a box anymore. We can put a title. The function for this is plt.title. The species is Ampelopsis acutifolia. And you can change your title and format it all the ways that you want. You can choose a font size. You can choose a style. Let's make it italic, because that's usually how people format the names of species. And you can do things like a font weight to make something bold, for example. So if we use these parameters for the arguments of plt.title, you can see we get a bold italic title. We can give names to our x and y axes. Let's just call them x values and y values. And you can see that we have x and y values for our 2 axes now that are named. And then you can even, there's all sorts of functions. So for example, this one, plt.axis, it can be either on, where you have all the values, or for example, it could be off. Maybe if we're drawing shapes like this, we'd rather not look at all the numbers on the axis. So they can be on or off. The whole point of this particular cell was to show you that there are many, many arguments and choices to make of within those arguments of which color, shape, or size of the different plot elements that you would like to use. The amount of choices you can make for a matplotlib graph are tremendous, And so I really recommend that you spend time exploring exactly what you can change on various matplotlib plots. Here are some links to kind of help you explore. This is one of the more creative aspects of coding. So really treat it like exploring. There's no wrong answers when it comes to visualization. So for example, all the different colors that you can use, these are all the named colors in matplotlib. You can refer to these by name. I also mentioned hex codes. There's numerous hex code generators that you can just Google and look up. So for example, within this color scheme, here you can see the hashtag, and this is the 6-character hex code. And you can change the hue, for example, and then change its lightness. And so you can see really the power in having the ability to choose almost any color that you want using these hex codes. And then one way to explore all the different ways you can do things in matplotlib is to look at sample plots. So I'll put this link also in the notebook, but you can explore, they have these galleries of different types of plots. And a really good way to learn matplotlib is if you have data and you have a particular type of visualization in mind, to go to this gallery and try to find the plot that you would like to make. And then you can look at the examples and try to figure out yourself all the things that you can do to create the plot that you want, and all the parameters and different choices that you have to make that visualization. So these links will be in the notebook. So that's about all the choices you have with shape and size and different types of choices you can make for data elements. Let's talk more about putting more than one data set in a plot and how to use legends. And so this is very easy. You've already seen how you can use multiple functions within one plot, but you can also use, you can call plt.plot multiple times with different data to give it different attributes. So for example, we're using plt.plot 3 times with 3 different grape species. This is Ampelopsis acutifolia, Vitis riparia, Vitis rupestris. We're giving them each a different color. But what we're doing here this time is we're using an argument called label. So we're giving this particular data a name. And this name is only for this data. You can see that's just the species name. Here it's Ampelopsis acutifolia. This label is Vitis riparia for the riparia data. And this label is Vitis rupestris for the rupestris data. We have our axes and set aspect ratio to make our plot proportional. We want our axes on. But now we have an additional function, plt.legend. And we're saying location in the lower left. Because what it's going to do, it's going to take these labels, and because we call plt.plot 3 times, it plots the data on top of each other. But because we have this label, when we give a name to each of these data sets, what happens is when we call plt legend, we can create a legend. And you can choose where it goes. Right now it's set at lower left. You could say lower right, for example. And it even has an option called best. So plt.legend will decide for itself what it thinks is the best location for a legend. So this is how you can create names for different types of data and put them into a legend. And finally, let's talk about subplots. What if we wanted to create one plot, but it had multiple panels, multiple plots within that plot? And this is where subplots comes into play. I will not lie, the code for subplots is a little complicated. I myself often just go and look it up each time that I want to use it, and you should do the same. I will put it in the notebooks whenever you need to use it in the class. But this is the general outline of what a subplot looks like. And let's go over it so we know how to use it when we need it. An alternative way to create a plot in matplotlib is to actually create a variable that is your figure. So you can use a function called plt.figure and assign it to a variable, usually we call it fig, where you store all the elements of your figure. You can put other attributes into this, for example, fig size. This is saying to create a 10-inch by 10-inch figure using this argument when we create the figure itself. Once you have your figure, then you use the .subplots function to create what we call an array. And so what we're doing here is we're modifying the figure that we just created using this function, subplots. The most important thing to know about the subplots is that you need to specify how many subplots you want. So in this case, let's create a 2 by 2 subplot. So this is always rows first, followed by columns. So this is a 2 by 2 subplot. Remember, rows followed by columns. This is creating another variable, and it's called an array. And basically what we've done here is you learned about indexing before, how if you have a list, for example, there's a start and an end, and every element in that list has a number and index associated with it. This is a two-dimensional indexing scheme, essentially. Remember, we were specifying 2 rows and 2 columns. And that's basically what this variable is, an array. Once we have this, these 2 lines of code, we have created our subplots, and we can get to business creating our subplot. So you can modify the figure directly. So this is called superior title, the title on the top for the overall figure, because it's modifying figure directly. We're going to call our overall figure title the shape of grapevine leaves. We can give it a font size and modify it like we want. But to create the subplots, this is where all the magic happens. So you created this array before, and remember, this is two-dimensional indexing. So the rows, the first value separated by a comma in these square brackets, because there's 2 of them, they're 0 and 1. So it's either the top or the bottom row, 0, 1. The second value is going to refer to the columns going from left to right. It's either the first column, 0, or it's the second one, 1. So we can refer to one of the subplots. We have 4 of them, right? So we can refer to the one in the upper left corner as 0, 0, the one in the upper right corner as 0, 1, the one in the lower left corner as 1, 0, and the one in the lower right corner as 1, 1. When you two-dimensionally index the array object like this, by 0, 0, for example, the functions that you use, .plot, .fill, .scatter, these will all modify just this one subplot. So you can do plot, fill, scatter. You can set a title even for just this one subplot. You can modify its aspect ratio, turn the axes off and on. So for example, this is the plot that we will create in the upper left-hand corner of our subplot. And again, you just go about creating the plot that you would like for the upper right-hand corner, the lower left-hand corner, and the lower right-hand corner. You can see that this is a lot of code, and we did a lot of things here. We created a figure object, then we modified the figure object with subplots to create an array. This array allows us, through two-dimensional indexing, to refer to each of the plots that we want to create. So this is a lot, but you can always look up the skeleton of how to make a subplots online and just copy and paste it from when you've used it before, or even in this notebook. So let's execute this cell, and this is what it looks like. So we created the overall figure. We can create a title for the overall figure, the shapes of grapevine leaves. But because we created this array with 2 rows, 2 columns, where the rows are 0 and 1, and the columns are 0 and 1, when we refer to and index that array object, we can modify each of these plots as we would like. So this creates a single overall plot with subplots. And this is how we can control and create different plots within an overall plot. So, what did we learn today? The Python learning objectives were that lists can store numerical data and that we can plot this data. We learned how to load in matplotlib, and there's other modules that you will learn about, and you import them similarly. We learned how to create plots and scatter plots and filled polygons, and we explored a bit about how to manipulate shape, size, and color of different elements in plots. We learned that you can plot data on top of each other and use a legend by creating a label for each of the different data that you use. And we can also create subplots. We can create multiple plots within a plot by creating an array using the subplot function. And by example, you saw today that the phenotype is what a plant is. Plants are amazingly complex, but we can try to measure what a plant is. We can try to measure its phenotype. You saw with an example of leaf shape that there are genetic differences between closely related species and that this results in variation. And shape is one of the aspects of phenotype that we can measure. And we measured it today using geometry, which is to say we measured it by the relationship of different points in a leaf to each other to create a shape. So thank you for watching. That's all for this video. Thanks.